Hello everyone, my name is Cole Emerine and I'm going to be discussing the application of the brain-computer interface in therapeutic recovery for stroke patients dealing with paralysis. Before we dive into that, I'd like to start off by painting a picture for you. Picture your brain like an Instagram account. Your brain has a certain number of followers and people following it. Within this social media network, there are different group messages, DMs, social interactions, including comments, likes, story posts. In this same manner, our brains have a web of connections, including sensory neurons, motor neurons, and central neurons. Central neurons are like the people your brain follows. They help you collect information through the posts they share, the comments they leave, and the DMs they send you. Motor neurons act like your followers. You post cute images for them, send them funny memes, and spread information to them. The central neurons are your brain, your account, your thoughts, the big processing center for what you're going to post and how you interpret the information that you see on other people's accounts. Your brain is like an Instagram account with this network of billions of neurons, constantly collecting input and output from its surroundings. The noise we hear, the light we see, the things we feel all act as inputs for our brain to interpret and act on through outputs such as speech, movement, thoughts. When a patient is recovering from a stroke, one main issue that can arise is a loss of functionality in a certain part of the body, such as their hand, arm, legs, and even their feet. During the stroke episode, blood was cut off to a certain part of the brain, and those neurons were damaged and are now unable to perform their job. In terms of our brain's Instagram account, that can mean that a glitch in the system shut off our ability to leave a like on other people's posts. When in reality, for example, this could mean that we lost function in our left hand. We can't wave hello or even give a thumbs up. Essentially, our left hand is paralyzed. So what can we do? We can wait it out for Instagram to fix the problem, or we could keep trying to leave a like until hopefully it works. But with newer technology and newer solutions, this brings me to, what is a computer interface? It's essentially as it's named, a connection between technology and our brain. According to Chamola in a 2020 article called Brain-Computer Interface-Based Humanoid Control, there are three main aspects to this system: collecting the brain signal, interpreting them, and inducing the outcome. To start off, we're going to look at how we collect the brain signals. Our brain is constantly sending signals out to other parts of the brain or even the body. These signals are made up of electrical impulses. So using metallic electrodes on a patient's head, similar to a sci-fi movie, we can gather these electrical signals in what is called an EEG, or an electroencephalogram. Then using artificial intelligence and specific computer algorithms, we can interpret these electrical signals into desired actions. This is similar to how Instagram uses our data to suggest certain advertisements. It always seems like whenever we're talking about something, it pops up in an ad. And this is due to pattern recognition software. So now that we know what the brain is trying to do, in our case with the left hand paralysis, according to Maine in a 2022 article titled Poststroke Motor Cognitive and Speech Rehabilitation with Brain-Computer Interface, functional electrical stimulation, or FES for short, may lead to the best possible motor recovery. What this system essentially does is, whenever the specific brain signals are recorded, which would be when the patient's trying to move their left hand, electrical shocks can be administered to the specific muscle groups in the wrist or hand to help retrain the pathways of communication from the brain all the way down to the hand. In terms of our Instagram account, this external device could act as a spam account that we use to like other people's posts in hopes of retraining our main account to complete the same action. The possibilities of this technology don't stop there. Similar to temporary paralysis, the brain-computer interface system can be utilized to even control prosthetic devices for amputees. With these robotic technologies still in development, currently, the benefits of the brain-computer interface will continue to shine through as a revolutionary therapeutic measure for recovering stroke patients with paralysis.